Electrical Energy Measurement, Part 5. Connections and Errors in Wattmeters. 1. The Connection Challenge. A wattmeter requires two coils, the current coil, CC, in series with the load, I, and the pressure coil, PC, in parallel across the load, V. However, since the instrument itself consumes power, there are two ways to connect the PC, and each introduces a small error. 2. Connection Method 1. PC inside, short shunt. In this method, the pressure coil, PC, is connected inside the current coil, CC. What it measures? The CC measures the current flowing to the load plus the small current used by the PC. Error introduced. The meter reading includes the small power consumed by the pressure coil itself, P_PC. This is a common method for high current, low voltage loads. Actual power, P_actual, is equal to P_measured, P_PC. 3. Connection Method 2, PC outside, long shunt. In this method, the pressure coil, PC, is connected outside the current coil, CC. What it measures? The CC measures only the actual load current. However, the PC measures the voltage across the load plus the small voltage drop across the CC. Error introduced. The meter reading includes the small power consumed by the current coil itself, P_CC. This is generally preferred for low current, high voltage loads. Actual power P_actual is equal to P_measured, P_CC. 4. Compensating connection. Advanced wattmeters sometimes include a compensating coil wound alongside the CC, connected to cancel out the effect of the PC current, thus greatly reducing connection errors. 5. Error due to PC inductance. In AC circuits, the pressure coil has an inherent inductance which causes its current to lag the voltage slightly. This means the meter measures a power factor different from the actual load power factor, introducing an error. 6. Temperature error. The resistance of the coils, particularly the resistance of the pressure coil's series resistor, can change with temperature. Since P proportional to V*I, resistance changes can slightly alter the coil currents, leading to measurement drift. 7. Eddy current error. The magnetic fields generated by the coils can induce eddy currents in nearby metallic parts, such as the coil supports. These parasitic currents create their own opposing magnetic fields, reducing the deflecting torque and causing the meter to read low. 8. Shielding against stray fields. External magnetic fields from other devices, stray fields, can interact with the meter's coils, causing false deflection. Wattmeters use robust magnetic shielding, often an iron casing, to mitigate this environmental error. 9. Creeping, not in wattmeters, but relevant to meters. While more common in induction energy meters, Part 9, it's worth noting that any residual current or torque can cause a continuous low-speed rotation, known as creeping in energy measurement, though less relevant to instantaneous power wattmeters. 10. Key connection takeaway. When connecting a wattmeter, always consider the load characteristics, high current, low voltage, to choose the connection that minimizes the percentage error relative to the true load power.